Most people slide into the driver's seat every day without ever thinking about the 4 circles of rubber beneath them. Yet those tires quietly do an incredible job, holding the road through sharp turns, helping the vehicle accelerate, and protecting everyone inside. But here's something surprising. Tires aren't just another part of the car. In many ways, they're the most important safety component a vehicle has. Over the years, improvements in tire technology have played a massive role in reducing road deaths by more than 80%. That kind of impact doesn't happen by chance. It's the result of decades of careful engineering. What makes this even more fascinating is how little rubber actually touches the road. At any given moment, each tire presses against the ground in an area roughly the size of your hand. Despite that tiny footprint, it handles heat, rain, cold weather, and enormous forces from the car itself. So how does something so small carry so much responsibility? To understand that, we have to go back to the beginning. Long before modern tires existed, early vehicles rolled on solid wooden wheels reinforced with metal bands. They were durable, but comfort and control were almost non-existent. Every bump in the road sent a harsh shock through the entire vehicle. Riding in one wasn't just uncomfortable, it could be dangerous. Engineers began experimenting with ways to soften the ride. One idea was to wrap wheels with leather to create a cushion between the wheel and the road. It helped slightly, but leather wore out quickly and provided very little grip. Rubber seemed like the obvious answer. It was flexible and naturally grippy, which sounded perfect for traction. But early rubber had a serious flaw. In hot weather it became sticky and weak, while in cold weather it hardened and cracked. A material that unstable simply couldn't be trusted on the road. Everything changed in 1839 when Charles Goodyear discovered a process known as vulcanization. By heating rubber with sulfur, he accidentally transformed it into something entirely different, stronger, more durable, and far more stable in different temperatures. Suddenly, rubber could handle real-world conditions. That discovery opened the door for the tire industry. Over the following decades, engineers didn't just improve comfort, they started designing tires with safety in mind. Which leads to another question: what exactly makes modern tires so effective? At first glance, a tire looks simple, but it's actually one of the most carefully designed parts of any vehicle. Its job isn't merely to spin, it must maintain traction, absorb forces, and keep the vehicle stable in constantly changing conditions. All of that begins with something called the contact patch. This is the small section of tire touching the road at any moment. Even though it's tiny, that patch performs 3 essential tasks. First, it moves the vehicle forward. When you press the accelerator, the tire pushes against the road. The road pushes back, and that reaction force propels the car ahead. Second, it helps the car slow down. When the brakes engage, friction between the tire and the pavement resists motion, allowing the vehicle to come to a controlled stop. Third, it allows the car to change direction. As you steer, the tire grips sideways against the road surface, guiding the vehicle through turns. All 3 of these actions depend on one critical factor: friction. Without friction between tire and road, a car would simply slide without control. This raises an interesting idea. If friction is so important, wouldn't increasing the contact area create even more grip? In some cases, that's exactly what engineers do. Look at drag racing, for example. Those cars use extremely wide tires designed to maximize the amount of rubber touching the track. More surface area means they can transfer huge amounts of power to the ground, launching the car forward with explosive acceleration. But for everyday driving, that approach comes with trade-offs. Wider tires increase rolling resistance, meaning the engine has to work harder. That leads to higher fuel consumption and reduced efficiency, something manufacturers constantly try to avoid. So while massive tires are perfect on a drag strip, they're not ideal for daily drivers. Instead, regular road tires rely on something much more subtle: tread patterns. If you look closely at a tire, you'll notice grooves and channels carved into the rubber. These patterns might seem random, but they're carefully designed for a very specific reason. When it rains, water builds up between the tire and the road. Without a way to move that water aside, the tire could actually ride on top of it. When that happens, the vehicle temporarily loses contact with the road, a dangerous condition known as hydroplaning. Tread grooves act like drainage systems. As the tire rolls forward, those channels push water away from the contact patch, allowing the rubber to maintain grip on the pavement. That's why tread design isn't just cosmetic, it's critical for safety. But if tread patterns are so important, why don't all tires use the exact same design? Wouldn't one perfect pattern work everywhere? Not really. Different environments demand different solutions, and tire engineers tailor designs for specific conditions. Using the wrong type of tire can sometimes be just as risky as driving on worn-out ones. Take summer tires, for example. They're built for warm temperatures and dry roads. Their rubber compounds are slightly firmer, which helps them maintain shape under heat and heavy loads. Their tread patterns are also shallower and wider, maximizing the amount of rubber in contact with the road. This gives them excellent grip on dry pavement. But once temperatures begin to drop, that same rubber starts to stiffen, and when that happens, the tire gradually loses the traction it once had. Winter tires solve a major problem cold weather creates for regular tires. Their rubber stays soft in freezing temperatures, allowing better grip, while deeper grooves dig into snow for improved control. However, this flexibility wears down quickly in warm weather, which is why winter tires aren't ideal year-round. Instead, many drivers choose all-season tires, which balance summer stability with moderate winter traction. Tire design also affects something most people rarely think about: road noise. Early tires used identical tread blocks arranged in repeating patterns, which caused a constant humming sound as they struck the pavement. Engineers eventually solved this with pitch sequencing, a design method that varies tread block sizes and spacing to break up vibrations and reduce noise. Safety improvements have also made tire blowouts far less common. Modern passenger cars use tire pressure monitoring systems, TPMS, that warn drivers when pressure drops too low. However, many large trucks still rely on manual pressure checks, which can increase the risk of overheating and tire failure. New monitoring technologies are beginning to change that. Tires today are tested extensively on wet tracks and precision rigs to measure braking, cornering, and durability under realistic conditions. But the biggest shift in the industry is coming from electric vehicles. Because EVs are heavier and produce instant torque, they wear out tires much faster, creating new challenges and new opportunities for tire manufacturers. Looking ahead, companies are developing airless tires that can't go flat and self-healing rubber that automatically seals punctures. If these technologies succeed, the future of driving may involve tires that are quieter, smarter, and almost maintenance-free. After more than a century of innovation, the humble tire continues to evolve, quietly keeping vehicles safe while most drivers never give it a second thought.